Good morning, everyone. I'm Varun Vijay from the electrical department, and I'm excited to welcome you all today. We'll be discussing the ICOG panel testing procedure and standard values. In this presentation, we'll cover the key steps involved in testing, the standard values we aim for, and best practices to ensure quality and safety. Let's get started. Today, I want to focus on the main objective of our testing process. Our goal is to ensure that the ICOG panel is both safe and fully functional before we energize the system. This means we need to carefully verify that everything is in proper working order to prevent any issues down the line. One key aspect is checking the control and protection circuits to make sure they are accurate. This is crucial because these circuits are responsible for safeguarding the equipment and ensuring correct operation. Additionally, we need to prevent insulation failures or contact issues under load conditions. This step is vital because any failure here could lead to serious problems once the system is energized. Overall, these checks are essential to maintain safety, reliability, and to ensure smooth operation of the entire system. Now let's take a closer look at the tests performed on the ICOG panel. First up is the visual inspection and tightness check. This step is crucial because it allows us to identify any obvious physical issues, such as loose connections or signs of damage, which could affect the panel's performance. Next, we have the insulation resistance, or IR, test. This test helps us ensure that the insulation within the panel is intact and effective, preventing any unwanted current leaks that could cause faults or safety hazards. Then there's the contact resistance measurement, or CRM. This measurement is important because it assesses the quality of electrical contacts within the panel, ensuring low resistance for efficient power flow and reliable operation. After that, we perform the current transformer ratio and polarity test. This helps us verify that the CTs are providing accurate current readings and are correctly wired, which is vital for precise measurement and protection functions. Following this, we conduct the voltage transformer or VT-PT ratio test. Similar to the CT test, this ensures that the voltage transformers are functioning correctly, providing accurate voltage measurements needed for system monitoring and protection. The next step is the functional, closing, and tripping test. This test simulates real operating conditions to confirm that the panel's protective and control functions are working properly, ensuring the system responds correctly during faults or operational commands. Finally, we carry out the interlock and indication verification. This step is essential to confirm that all safety interlocks are correctly configured and that the indicator lights and alarms are functioning, helping prevent unsafe conditions and ensuring proper system operation. Together, these tests form a comprehensive approach to validating the ICOG panel's performance, safety, and reliability, which are all critical components in maintaining a secure and efficient power system. Let's go over the equipment required for these tests. First, for the IR test, you'll need a 5 kV or 1 kV megger. This device is essential for measuring insulation resistance, helping us ensure the insulation integrity of the equipment. Next, for the CRM test, a micro-ohm meter, also known as a DLRO, is used to measure low resistance values, which is critical for checking the condition of connectors and bus bars. Moving on, for the CT and VT ratio tests, a primary injection kit is necessary. This kit allows us to inject a known current directly into the transformer to verify the ratio accuracy of current and voltage transformers. For the functional test, we use a secondary injection kit to simulate the operation of protective relays and ensure they respond correctly under actual conditions. Finally, for the interlock check, a multimeter or a control supply is required. This helps us verify that interlocks are functioning properly, preventing unsafe operation and ensuring system safety. All these tools are vital for comprehensive testing, ensuring our equipment performs reliably and safely within the overall system. Let's talk about the insulation resistance, or IR, test. The main purpose here is to ensure the insulation health between the phases and between the phase and earth. This is crucial because good insulation prevents unwanted current leaks and potential failures. The procedure involves applying a megger between each pair of conductors. So, you test phase to phase and phase to earth, making sure everything is properly insulated. Now, regarding the standard values for low voltage panels, we look for a minimum of 1 gigaohm and for medium voltage panels at 10 gigaohms when testing at 5 kilovolts. These numbers help us determine if the insulation is in good condition. It's important to note that if the insulation test is bypassed, it could lead to serious problems, like short circuits or tripping during operation. That's why thorough testing is essential for safe and reliable system performance. Remember, this IR test is a key part of the overall maintenance and safety checks we perform to keep the electrical system running smoothly. Let's talk about the contact resistance test, or CRM. The main purpose of this test is to check the tightness of busbar and breaker contacts. Ensuring good contact is crucial because poor contact can lead to a number of issues. Now, in terms of standard values, for low voltage systems, the contact resistance should be less than 100 microohms, and for high voltage systems, it should be less than 200 microohms. These thresholds help us determine if the contacts are performing properly. It's also important to note what happens if this test is bypassed or if the contact resistance exceeds these limits. Bypassing or having high resistance can cause heating at the connection points, which is a serious risk. It can also lead to voltage drops that affect system performance, and in worst cases, arc faults that could cause equipment damage or safety hazards. So always remember that maintaining proper contact resistance is key to the reliability and safety of the electrical system. Regular testing and adherence to these standards help us prevent failures and ensure smooth operation. Let's talk about CT ratio, polarity, and magnetization. The main purpose here is to verify that the CT ratio, polarity, and burden are all accurate. This is essential because if any of these are off, it can affect the overall protection system performance. To do this, we use a primary injection kit, which allows us to simulate the current flowing through the CTs safely and accurately. We have a standard to follow. The ratio error should be within plus or minus 0.5%, and the polarity must be correct. Why does this matter? Well, if the CTs are bypassed or connected improperly, it can send the wrong current input to the protection relay. This can lead to relay malopration, meaning the protection system might not act when it should, or it could trip unnecessarily. In essence, verifying these parameters ensures that our protection system functions reliably and accurately, maintaining the safety and stability of the electrical network. Let's take a closer look at the PT/VT ratio test. The main purpose of this test is to verify the secondary voltage and phase angle. Ensuring these are correct is crucial for the accurate operation of protective devices and metering systems. The standard we aim for is that the output should match the rated ratio, with a tolerance within plus or minus 0.5%. This small margin helps us confirm that the transformer is performing accurately and reliably. Now, if this test is bypassed or not performed properly, it can lead to metering errors and relay operation issues. These errors could result in incorrect system readings or even improper relay actions, which might compromise the safety and stability of the system. So, in essence, the PT/VT ratio test is a vital step to ensure that all measurements and protective functions are working as intended, maintaining system integrity and safety. Now, let's talk about the functional and interlock test. The main purpose here is to make sure that everything operates correctly, so that the breaker, trip coil, on/off indicators, alarms, and interlocks all work as they should. It's essential that all these components function together seamlessly to maintain system safety and reliability. We expect all sequences to run smoothly, meaning no unexpected delays or failures during operation. If the system is bypassed, however, that can lead to serious issues. For example, the operator might face unsafe conditions or the breaker could misoperate. That's why proper testing and adherence to procedures are so critical. Remember, this test isn't just about verifying components. It's about ensuring the entire system's integrity and safety. When everything functions correctly, it helps us prevent accidents and maintain stable operations. Let's take a look at our results summary. First, the CT ratio measurements proved to be accurate, with the 301A and 601A readings confirmed through verification. This is important because it shows our equipment is functioning correctly and providing reliable data. Next, our insulation resistance readings were above 200 megaohms, which is well within the standard range. This indicates good insulation quality and suggests there's no immediate concern there. Moving on, the CRM results were satisfactory, meaning the core monitoring aspects are performing as expected. Lastly, both the tripping and closing functions are operational, which is crucial for the overall safety and reliability of the system. When we connect all these points, it really highlights that our system is in good shape, and the tests confirm everything is working as it should be, supporting the overall goal of ensuring system safety and efficiency. Let's talk about safety and precautions, which are absolutely essential when working with electrical panels. First, always ensure that the panel is fully isolated before you start testing. This means disconnecting it from the power source to prevent any accidental energization. Next, only use calibrated instruments. Using properly calibrated tools ensures that your measurements are accurate and reliable, reducing the risk of errors. And of course, follow lockout-tagout procedures, LOTO, to secure the panel and prevent anyone from accidentally turning it back on while you're working on it. These safety steps are vital not only to protect yourself, but also to maintain the integrity of the system and ensure a safe working environment. Remember, safety always comes first, especially when dealing with electrical equipment. And that brings us to the conclusion. All tests we've conducted confirm that the panel is healthy and fully ready for service. This is a crucial reassurance that everything is functioning as it should. Remember, preventive testing plays a vital role in minimizing unexpected breakdowns. By catching potential issues early, we can ensure continuous, reliable operation. This approach not only keeps the system running smoothly, but also extends its lifespan. So, in summary, regular testing and maintenance are key to maintaining high reliability and performance. Thank you for your attention, and I hope this overview helps reinforce the importance of proactive management.